A lot of computer development has been driven by the military. I mean, the internet essentially started as a military project.
Right.
Because I guess that's considered to be one of the basic needs to have a strong military. Now, since anything that can be turned into a weapon probably will be at some point, is there a danger that if the technology gets too powerful, it's going to end up killing us all as we turn it on each other?
Well, yes and no. I mean, you can run that scenario, and that's one scenario that you can run, but my colleague Kathleen Marr says that you can take any technology and they'll turn it into a game. And so very early in the development of computers, back into the 1960s in fact, one of the first things that was done on computers was we made games out of them. We played ping pong on computers in laboratories at MIT. So you can have a death scenario with, a war machine, or you can have a fun scenario with computer games, and everything in between.
Yeah. And some people say that games are a waste of time. Too many kids spending their time playing these games, but games can also have a very practical purpose.
That's right.
They can train you in all kinds of useful skills, sharpen your reflexes in many ways, do all kinds of things.
That's absolutely correct, and that's been proven many, many times. Students who have had some learning disabilities and who have had some actual mechanical disabilities have improved their reflex time, their response time, even their micromotor skills. There's also been situations where people who have played racing games, and these are racing games where you actually have a little steering wheel that you hold and you can steer the car and look at the computer and so forth, that those people have improved their driving skills. Just like I mentioned the airplane simulator in training, you can do the same thing with a car, you can do it with a boat, a truck, anything that moves that you need to develop your skills and your acuity for watching what's going on can be improved by gaming.
Well, another whole field of interest could be the whole educational field. If with the right graphics, people could maybe grasp concepts a lot more quickly, like if you're teaching physics or chemistry, if you have impressive enough graphics, it'll be a lot easier than going through that musty old textbook with all those formulas.
That's absolutely correct. And again, there is a famous developer who did this. His name is Jim Blinn out of Caltech, and he put together a whole bunch of series on television where he did exactly what you just said. He showed the principles of physics and chemistry, by the way, using computer graphics to create the models. And it was a stimulating program because the graphics were attractive. So it was interesting to look at them, and at the same time you were learning about the laws of physics.
Yeah. And we'll probably see a lot more of that. And there are a lot of online courses you can take now. You don't even have to go to a school anymore. And pretty much anyone can teach these courses, although some of them have more prestige than others. And some of them do rely on fancy graphics to get concepts across. Like the difference, I guess, between the right brain and the left brain. Some people prefer images and some people like linear text.
Well, and let me just make a point about that also. This is a tech show, and we've been talking about tech, but in the case of learning in school, there are a lot of learning situations in history and in the arts where people are being taught how to paint, how to understand lighting for painting. People are being taught about history through computer-generated reproductions of historical events that are very realistic. And so they get a different sense of the history story when they can see models of how these people behave towards each other. And that has evolved then into games. There's a game now called Napoleon, where you can be Napoleon and fight his battles.
I've always wanted to be Napoleon.
Haven't we all?
Right. So this graphics could be used for fantasy fulfillment. It could be used for a lot of things.
That's right.
I guess.
That's right.
Hopefully it'll be used mostly for positive things.
It permeates our entire life. You can't watch a movie, you can't watch TV, you can barely look at your telephone, your smartphone, and not be involved with computer graphics. It is just totally all around us everywhere. The dashboard of your car, the next generation of cars will have a totally electronic dashboard. And you'll be able to design your own dashboard. You'll be able to say, I want the speedometer over here, the tachometer over there, I want this one red, this one green. You'll be able to do that.
So everything's going to be totally custom made.
Can be, yeah.
Okay.
Yeah.
So this is very powerful stuff. It's really affecting our lives in ways that I'm not even sure that we know how it's affecting our lives, but it's going to have a pretty big effect.
We really don't. We can't fully predict it, but it's been a great ride getting here, let me tell you. It's going to be a better one.
Now, we're seeing an increase of crowdsourcing here, where it used to be a few scientists working in their labs, but now with the internet, people can share information so much more quickly that the process of design is speeded up, like the whole maker movement, for example, where people get together and they put their heads together and come up with incredible things that previously working alone would have been very hard.
Yeah, and there's another aspect. You remember I told you about this Moore's Law thing, right? So in the process of Moore's Law working its way through time, we've had what we call a democratization of CAD, computer-aided design. It used to be, not so long ago, maybe 5 or 6 years ago, if you wanted to do a CAD design, you'd have to spend $10,000 to $20,000 on a computer. You'd have to spend $20,000 to $50,000 on the software. You'd have to buy an expensive monitor, and then you'd have to be trained on it. Today, you can do that entire thing for under $5,000. You can get a computer for $1,000 or $2,000. You can get a CAD program for a couple $100 today. You can get a monitor for $500, and the training is online, like you pointed out before. There's a program called .Linda where you can learn almost anything for a few dollars, and they have these nice short courses. And so to your point about the Maker Faire, you can buy this stuff, you can make stuff, and then you can take it to your local 3D printer shop and have them make it for you.
You know, we just have about a minute left. If a young person wants to get into the field of computer graphics, what would be a good place to start?
Almost anywhere. You can start as an artist. Think about all the art that goes into creating movies and computer games and designs of cars and the interiors of cars and things. You can start as a mathematician. All of this stuff is math-based. You can't make it work without mathematics. You can start as a hardware engineer. Someone has to design and build and manufacture the chips. You can start as a software engineer. This is all coded up. Just the opportunities are almost endless.
Okay, very good. And we're going to have to wrap on that note because I've gotten the signal. I'd like to thank you for being here today. Jon Peddie, president of Jon Peddie Research. You've been watching Future Talk. I'm Marty Wasserman. Visit our website, www.futuretalk.net. For Future Talk, see you next time.